Hey, so this is going to be your first lab. It's our orientation lab, and it's all about graphing. So why graphing is important is because it's a way that we represent data to those who weren't there for the experiment. So it's important that we learn how to graph and also learn how to read a graph. So in this particular lab, you will learn the different types of graphs that we'll be using, as well as the different parts of each graph. And in this particular lab, you are provided with graph paper that you can print out and use to make your graphs. One of the things in my class, of course, is that everything has to be typed or digitally submitted. You are going to be hand drawing your graphs, but then you will either scan that or you can use your camera on your phone to take a picture, and you'll insert that into the Word document that you'll be sending to me. So as you go through, make sure you're familiar with the different parts of the graph. And there are just a couple of things that I'd like to draw to your attention, kind of some tips and tricks on how to do this particular lab well. Okay, so one of the things that's helpful is what we call tails. This makes sure that you get all the parts of your graph correct. So T is for the title, and I'm going to skip that for now. We're going to come back to title. A is for axes. You need to make sure that you have correct labeling of your axes, that you always include what units are being used. So for example, in this one, across the x-axis, we're measuring time, and in this case, time is being measured in hours. So those are both represented. I use consistent intervals. So when you are looking at your scale, every single tick mark needs to be the same value or the same interval. So as we were talking about before, we have 1, 1.2, 1.4, 1.6. Those intervals are 0.2, 2/10 of an hour. So those need to be consistent. The other thing I will say is oftentimes in high school, we start every graph with the scale starting at 0. And that is not going to be the case in our class. And I think you'll notice this on the first graph that you do. Starting at 0 would just waste a whole lot of space. So for example, in this graph, the x-axis starts with 1. Note that it didn't start with 0 because everything to the left of 1 would have nothing in it, and that would be a waste of the space. So pay careful attention to that when you are doing your lab this week. Label. Basically, you want to make sure that you have a key if it's necessary, so that like if you have more than one thing graphed on your graph, you need to have a key with it so that whoever is looking at it can understand what each line represents. Okay, and then the size, and this is pretty important. Use your entire graph paper. That's the way that it's going to make it the most legible, basically. And so when you print out your sheet of graph paper, make sure that your intervals on your scale are such that the data will use up the most amount of space. Okay. Okay, so you'll notice that one of the types of graphs that you're asked to draw is a line graph. And that doesn't necessarily mean a straight line, although sometimes it does. Oftentimes it's going to look like this particular one that you see on your screen here, which is a bell-shaped curve, but it is still represented by a line. So that's what we mean when we say a line graph. The other thing to note is that not every data point is going to be on the line. So you'll notice here, this one's a little further off. This one's not exactly on the line. Neither is this one, and neither is this one. And so what we want is what we call the best fit line. And that just means a line that represents the average of where your data points are. So when you submit your work, I do not want to see dot to dot. That is not what we are about. So your best fit line is going to be one that represents the average of your data points. So I wanted to make sure I pointed that out. Okay, this is super important to me. If you've talked to any of my previous students, you will know that I am very picky about titles of graphs. So here are some hints about that. Anybody should be able to look at your graph, read the title, and know pretty much exactly what you did in this data, in this experiment, what it represents. Sometimes you can even summarize your data within your title as long as it is detailed. So it is not like a book title. We're not looking for anything frilly or funny or entertaining. This is science. It can be very dry. It just has to be informative. So for instance, in this graph, the title, "The Number of Deer Observed in 24 Hours in a Farmer John's Hunting Field on Selected Days in October of 2007. You'll notice it's very wordy, but it's very descriptive. So we don't want to be descriptive in such a way that it's unnecessary, but we want to relay all the relevant information. So I will be looking for titles that are descriptive. I never want to see the word versus in your title. So if you told me here, number of deer versus dates in October, I would not give you credit for that. It doesn't tell me anything. And it tends to be what people in high school will do. And I'm not sure why high school teachers aren't telling you to do that differently, because it really provides no information. So, so just go ahead and know that if I see the word versus in your title, no credit. So be very descriptive in your titles. Okay, this should help you with your first lab, and I look forward to seeing what you guys can do. Let me know if you have any questions.